Welcome to this class. Today I am going to start one of the very important chapter related to the subject Science and Technology of class 9, and the name of the chapter is Force and Motion. Okay, this chapter is full of different terms, different definitions. That's why today's class is focused on different terms and definitions. These terms are distance, displacement, speed, velocity, average velocity, uniform velocity, non-uniform velocity. In the same way, there are other terms also: scalar, vector, acceleration, retardation, and acceleration due to gravity also. I am going to define all these terms with the help of diagram. Okay, let's start. Distance and displacement first. I want to show a diagram and then I will explain about the distance and displacement. Look at the screen. Look at this is, let's say, a reference point, and a body is starting from reference point. It moves somewhere towards right hand side, towards left hand side somewhere, and this is marked as 0. And if it moves towards right hand side, then to measure the distance, I want to produce certain mark in right hand side, and it is marked as 1 meter, 2 meter and 3 meter. Let's say these are the distances towards right hand side. But if the body moves towards left hand side, then we must have mark again, and this is the mark for 1 meter, 2 meter and 3 meter. But why I marked minus? The reason is very simple. Our reference direction is towards right hand side. If a body moves towards right hand side, then the distance traveled can be considered to be in the reference direction. But if it moves towards left hand side, then distance is traveled in opposite direction. That's why to find out the distance traveled in right hand side or reference direction or not, the left hand side marking is negative. Okay, now let's start. If a body start to move from this 0 and it reaches to mark 2, then we can say that it covered 2 meter distance. Length of the path covered by the body is 2 meter. That's why distance is 2 meter. But after reaching to the point 2, if it returns back and move towards left hand side, let's say it goes to -3 mark, then how much distance it covered? 1 meter, 2 meter, 3 meter, 4 meter and 5 meter distance is now covered towards left hand side. That's why, what can I say? The total distance covered is 2 meter plus 5 meter is 7 meter. Now, length of the path covered by the body is 7 meter till now. If the body is continuously moving and it returns back, and if it reaches to this mark 1, then again it covers 1, 2, 3, 4 meter distance towards right hand side. Now altogether the length of the path covered by the body is 2 meter plus 5 meter plus 4 meter. This is equal to what? 11 meter. And exactly this is the distance covered by the body. Distance is not related to the direction, whether the distance is covered in left hand side or right hand side or towards upward direction or towards downward direction. It doesn't make any difference. But the total length of the path covered by the body is 11 meter, and this is called distance covered by this body. But finally it came to this point. It means finally it came to mark 1. What it means? The distance, shortest distance between initial and final position of the body is 1 meter only. This 1 meter is the displacement. The length of the path covered by the body is the distance covered by the body, but the shortest distance between the initial and final position of the body is called displacement. Now after this much understanding, now I want to define exactly what is distance and what is displacement. Let's start distance. What is it exactly? The length of the path covered by the body is called distance covered by that body. Length of the path, whether the length is covered in positive direction, negative direction, or circular, or whatever it is, but the length, total length covered by a body represents the distance covered by that body. It is denoted by small d. The symbol for distance is small d and its SI unit is meter. Okay, this is the definition of distance. Now displacement. How can we define displacement? The shortest distance between the initial and final position of the body is called displacement. What it means? No matter the body covers distance towards left hand side or right hand side or towards east direction or towards west direction, it doesn't make any difference to displacement. Finally, where is the body and what is the shortest distance between its initial and final position? That represents the displacement of the body. That's why I want to return back to again the same diagram, but remember, displacement is symbolized by the symbol S and its SI unit is meter. Both of them have same SI unit, meter, but one has definite direction, another doesn't have definite direction. Okay, I want to come back to the same diagram. Look at this diagram. In this diagram, what is seen? Total distance covered by the body is 11 meter, but displacement is only 1 meter. But instead of this final position, if the body moves to this direction and reaches to -2 mark, then it covered again 1, 2 and 3 meter distance. That's why total length of the path covered by the body is 14 meter. Yes, it is very simple, but the displacement is not same. Displacement is not 1 meter. Now the final position of the body is this, initial position is this, it is 2 meter away from the initial position, but just opposite of the reference direction towards left hand side. That's why this displacement is negative. So we can say that displacement is -2 meter. It means displacement may be negative, it may be positive, it may be 0 also. If it again comes back to the same reference point, then the distance between the initial and final position becomes 0. That's why displacement becomes 0. Displacement may be negative, may be positive, or may be 0. But distance never be negative, never be 0. Okay, after this much understanding, now I want to tell you some more example, graphical representation of distance and displacement. Look at this graph. In this graph, this is x-axis, this is y-axis, you know about this. Now, I am considering the middle point, this 0 point. Let's say this is point O and a body start to move from O and move towards right hand side, and when it reaches to mark 3, it covered 3 meter distance when it reaches to point A. Now after reaching to point A, if it moves upward like this and reaches to point B, then it covered 4 meter distance. Total length of the path covered by this body is 3 meter plus 4 meter, that is 7 meter. Distance is 7 meter. Distance is not related to direction, that's why whether it is towards east or towards west or upward or downward, the total length of the path is 7 meter. But displacement is different. What is the distance between O and B? This is the shortest distance between initial and final position, and this represents displacement. That's why displacement cannot be 3 also, cannot be 4 also, and cannot be 7 also. Displacement cannot be obtained by adding 3 and 4. We have to use some formula to get the displacement, and this is the formula. Pythagoras formula, OB square equal to OA square plus AB square. Hypotenuse square equal to base square plus perpendicular square. And it can be converted to, this can be converted to OB equal to OA square plus AB square. If we take the value, then 3 square plus 4 square, which gives 9 plus 6 and root over 25, and if root over is removed, then we will have 5. It means displacement is 5 meter. The distance between O and B is 5 meter. This is the shortest distance between initial and final position of the body and is called displacement. This way graphically also we can understand about the displacement. Now I think I made you very clear about the distance and displacement. One has direction, one doesn't have direction. Both of them have same unit, but they are totally different quantity. Okay, now we are talking about speed and velocity. I want to present one diagram. With the help of diagram, I want to make you clear about the speed and velocity. What is the similarity and what is the difference? Look at this diagram. Let's say this N represents north direction. Certainly opposite of north is south, and E represents east direction. Opposite of this is west. Now if a body start to move from A, let's say a car start to move from A and it is moving towards east direction this way. Now after reaching to a point B, it turns, but while moving from A to B, it covers 5 meter distance in every 1 second. It means the rate of motion is 5 meter per second. When it reaches to B, then instead of moving straight, now it is turned towards south. Now when it moved towards south, its rate of motion is 5 meter per second. Again it covers 5 meter distance in every 1 second. And when it reaches to C, instead of going straight, it returns back to the direction, another direction, that is west, and reaches to D with the same rate of motion 5 meter per second and moves to D. Looking at all these, what can we say? Throughout the journey, it covers 5 meter distance in every 1 second. This is its speed. The distance covered by a body in unit time represents the speed, and its speed throughout the journey is 5 meter per second, but velocity is different. Look at this velocity. Velocity while going from A to B is 5 meter per second, because velocity towards east is 5 meter per second, direction is considered. When it turns towards the south direction, then its velocity becomes 0. Now it is not moving towards east, neither it coming back towards west, it is moving towards south. At this time direction is not covered, distance is not covered towards east direction, that's why its velocity is 0. But when it moves from C to D, then its velocity is different. Now instead of moving towards east, it is moving towards just opposite, west. It means its velocity is now minus 5 meter per second, because it covers 5 meter distance towards west in every 1 second. Throughout the journey, speed was same, but the velocity is different in different path of its journey. Okay, that's why speed is not related to the direction, but velocity is related to direction. When direction changes, the value of velocity keeps on changing. Okay, after this much understanding, what is speed? Now I am going to define this. The distance covered in unit time is called speed. No matter the distance is covered towards east direction, west direction, north or south, it doesn't make any difference, but the distance covered in unit time is called speed. Its SI unit is meter per second, and it can be calculated by using this formula: speed equal to distance covered d upon time taken t. Okay, now let's go to another point, velocity. How can we define velocity? Velocity can be defined this way: displacement per unit time is called velocity. Or we can say this way also: distance traveled by a body in a definite direction in unit time is called velocity of that body. Distance traveled by a body in a definite direction is displacement, and displacement in unit time is called velocity of that body. Its SI unit is meter per second. It means both the speed and velocity have same unit, meter per second, but formula is a little different. Velocity is equal to displacement s by time t. This way we can define velocity. Till now, I think you have a little clear idea about the distance, displacement, speed and velocity. Have you noticed that some of them have direction also, but some of them do not have direction? According to this concept, I mean to say, there are hundreds of physical quantities in the study of the physics. Some of them have magnitude as well as direction. They are called vector quantity. But some of them have only magnitude, not a definite direction. That quantity is called scalar quantity. Now, all the physical quantities can be broadly divided into two types. One, vector, another scalar. Now, I am going to define these two terms. Scalar quantity, exactly what is it? The physical quantities which have only magnitude are known as scalar quantity. The quantity which have only magnitude are known as scalar quantity. Just for example, I want to give you more example. Mass of a body is if 2 kilogram. 2 is a number, kilogram is the unit. This number and unit gives the magnitude of the mass. It is 2 kilogram. But can we expect about its direction? No, mass doesn't have any direction. Mass may be 2 kg, 4 kg, 5 kg, but if someone asks you in which direction this mass acts, then you cannot say anything. That's why mass doesn't have any definite direction. It has no direction at all. This is scalar quantity. But if someone says what is vector quantity, then we can reply this way: the physical quantities which have both the magnitude and direction are known as vector quantity. Just for example, if someone says the weight of this body is 2 Newton, then number 2 and Newton unit, number and unit, these two, number and unit, represents the magnitude of the weight. But magnitude of the weight has direction also. Weight of a body is the force with which earth attracts the body towards its center. That's why the direction of weight is towards the center of the earth. That's why weight has both the magnitude and direction. Okay, after this much understanding, I want to differentiate vector and scalar with certain points. Look at these points. Vector, it is expressed in terms of both the magnitude and direction, but scalar is expressed in terms of only magnitude, and its value may be positive, negative or zero. Vector may be positive, may be negative and may be zero. I told you about displacement, its value may be negative, positive or zero. That is vector. And scalar, its value is always positive, it never be negative. We cannot expect that mass of a body is minus 2 kilogram. Next, it can be represented by a straight line with an arrow head, where the length of the line represents the magnitude and the arrow the direction. What it means? Just for example, if we have to represent 2 Newton force, then we can draw 2 centimeter long line and an arrowhead can be given to it. The length of the line represents 2 Newton force and arrowhead represents the direction of the force. But this scalar quantity, it is not represented by the straight line and arrowhead. Now another one, it cannot be added, subtracted or multiplied by the simple algebraical rules. Just before this, I told you about this displacement. 3 meter distance is covered in right hand side and 4 meter distance is covered in upward direction. Now we cannot say that displacement is 7 meter because simple algebraical method cannot give the resultant displacement. But scalar quantity can be added, subtracted or multiplied by the simple algebraical rules. If we have 2 kg sugar, 1 kg is added to it, then 2 kg plus 1 kg become 3 kg, or 1 kg is removed from that 2 kg, then 2 kg minus 1 kg gives 1 kilogram. This way, simple addition, subtraction and multiplication can be done with the scalar quantity, but vector quantity cannot be represented or cannot be added or subtracted or multiplied by using simple algebraical rules. Okay, after this, I want to go through one question. We have done distance, displacement, speed, velocity, scalar and vector quantity. Now I want to present one question. This is question time. I want to present one question and I want to evaluate whether the subject matter is understood or not till now what is taught. Okay, look at this. Statement is given. Displacement and speed both have same unit. Is this correct? Evaluate yourself. This saying is correct or not? This statement is correct or not? Now there is another point. Argument is told. Argument 1. Both of them have the value positive, negative or 0. Is it correct? Both of them have negative, positive or 0. They can have negative, positive or 0 value. Another argument is there. Displacement has a definite direction but speed doesn't have a definite direction. Now we have to check all these and we have to conclude whether the option 1 statement is correct, both the arguments are incorrect is correct, or option 2 is correct, option 3 is correct or option 4 is correct. Which one is the correct option? We have to select out of 4 one. Okay, now how can we check it? Look at this. Number 1, statement is correct but both the arguments are incorrect. Now check it out. Statement is correct or not? Displacement and speed both have same unit. This is not correct because displacement is measured in meter but speed is measured in meter per second. That's why they do not have same unit. So option 1 is not correct. I want to cancel it. I don't want to go to arguments because statement is correct is wrong. Why should we go through argument? Now 2. Both the arguments are correct but the statement is incorrect. Now let's go through argument. Both of them may have the value positive, negative or 0. Is this correct? No, this is also incorrect because displacement is a vector quantity. It can have positive or negative or 0 value, but speed is always positive. That's why this option number 2, both the arguments are correct is told. First argument is found to be incorrect, so I don't have to go through argument 2 and statement also. Number 3, only the argument 1 is correct. Is this correct? Just now I told you that argument 1 is incorrect. That's why 3 is also cancelled. Now number 4, only the argument 2 is correct. We haven't seen argument 2. Look at this argument 2. Displacement has a definite direction but speed doesn't have a definite direction. Yes, this is true because displacement is a vector quantity. It has a definite direction and speed is a scalar quantity. That's why it has no any definite direction. This is correct. That's why we will select this 4th option out of these 1, 2, 3, 4. Okay. Now let's talk about other type of motion also. There is another type of motion called uniform velocity. Now what is uniform velocity? I want to present one diagram first and then I will explain about the uniform velocity. Look at this diagram. Let's say a body start to move from this point and moving towards this direction, and after every 1 second it reaches to this mark. At first it is at this position, after 1 second here, after another 1 second here, another 1 second here. After every 1 second it covers certain distance. This is 0 second, this is 1 second, this is 2 second, this is 3 second and 4 second. And distance covered in every 1 second is found to be 5 meter. Very interesting. What it means? In equal interval of time, this body covers equal distance. In 1 second time, in every 1 second time, the body is in 5 meter away from its initial position. Now this is the diagrammatic representation of uniform velocity. Now we can define uniform velocity this way. In every 1 second it covers 5 meter distance, and if we check the distance covered in half second, it is found to be just half of 5 meter, that is 2.5 meter. Another half second 2.5 meter, another half second 2.5 meter. In this way, if it covers equal distance in equal interval of time, However small these intervals may be, then the body is said to be moving with uniform velocity. We can define this way. Look at the definition. A body is said to be moving with uniform velocity if it covers equal distances in equal interval of time, however small these intervals may be. This is the definition of uniform velocity. Now let us talk about non-uniform velocity or variable velocity. I want to present one diagram again. Let us say a body is moving towards this direction and these are the mark after every 1 second where the position of the body. Now if it covers first 5 meter distance and second 4 meter distance, in third second 7 meter distance and fourth second again 5 meter distance, then what is seen here, in every equal time interval body does not cover equal distance. If distance covered by the body is not equal in equal time interval, then the body is moving with variable velocity, or if it changes the direction also, then body is said to be moving with variable velocity. We can define like this: variable velocity. A body is said to be moving with variable velocity if it covers unequal distances in equal interval of time, or it changes the direction of motion. This is variable velocity. Now let us talk about the average velocity. What is average velocity? If total distance covered by a body in a straight line is divided by total time taken to cover that distance, then we will get average velocity. Now average velocity is actually the ratio of total distance covered by total time taken. Ratio of total distance covered to the total time taken. We can define this way: the ratio of the total distance covered by the body in the definite direction to the total time taken to cover that distance is known as average velocity of that body. This is a very simple definition. Now it is time to talk about another type of motion, that is called acceleration. Look at this. What is acceleration? Do you know what is acceleration? It was taught in lower class also. I want to go through one of the diagram. Look at this, is the line in which a body is moving. Let us say it is moving in this straight line path, and there is a marking, initial marking. At this time the body is at rest. After 1 second its velocity is, let us say, 5 meter per second. After another 1 second its velocity 10 meter per second. In the same way 15 meter per second and 20 meter per second. A body is moving in such a way that every second its velocity is increasing and increasing and increasing. This type of motion of the body is called acceleration. And now I want to present another diagram also. Look at this. In this case, every second the velocity is decreasing and decreasing and decreasing. What it means? The change of velocity is found after every second. Change of velocity in unit time is called acceleration. What is the change of velocity of the body in every 1 unit time? That represents the acceleration. That is why what can we say? The rate of change of velocity is called acceleration. Its SI unit is meter per second square. And it can be represented by this equation: acceleration equal to change of velocity by time taken. And symbolically what can we say? The final velocity is if v and initial velocity is if taken u, then final minus initial is change of velocity, and this change if takes place in time t, then change of velocity by time taken can be represented symbolically a equal to v minus u by t. Okay, now another term, retardation. Exactly what is it? Retardation. Retardation is same as acceleration. I mean to say retardation and acceleration are same, but negative acceleration is retardation. Then how can we define it? We can define this way: the rate of decrease of velocity is called retardation. Rate of decrease, whether the rate of increase or decrease, that represents acceleration, but particularly if velocity goes on decreasing, then rate of decrease of velocity is called retardation. Now, have you noticed when an aeroplane lands in the airport, then what happens? When its wheel touches the runway, every second its velocity goes on decreasing and decreasing, and this is the example of retardation. But when the same aeroplane takes off the airport, then in every second its speed or its velocity goes on increasing and increasing and increasing before flying up, and this is the condition of positive acceleration. Both of them are acceleration, but rate of decrease of velocity is retardation and rate of change of velocity is acceleration. Okay, now after the understanding of different types of motion, I want to present another question also. Look at this question. Statement is given, when a stone is thrown vertically upward, positive acceleration produces on the stone. Is this correct? When a body is thrown vertically upward, its acceleration is positive. Correct or not? Just think about this. Now there is one argument. Argument is deceleration produces on the stone when it moves upward. Deceleration produces. Check it out. Another one also given. Argument 2, stone gains maximum velocity when it reaches to the maximum height. Is this correct? After checking all these statement and argument, you have to select one of the option, whether this first, second, third, fourth, which option is correct. Now I want to go through each of them. Number 1, statement is correct but both the arguments are incorrect. Is this correct? Let's check statement. When a stone is thrown vertically upward, positive acceleration produces on the stone. Is this correct? No. If a stone is thrown vertically upward, every second its velocity goes on decreasing and negative acceleration produces. That's why this statement is not correct. And option 1, I am going to cancel it. Now we are not selecting this. Number 2, only the argument 1 is correct, but argument 2 and statement are incorrect. Argument 1 is correct told, so I want to check it. Deceleration produces on the stone when it moves upward. Deceleration means retardation. If a stone is thrown vertically upward, yes, retardation produces on the stone when it moves upward. This is correct. But number 2 doesn't say only about argument 1, but it also says argument 2 and statement are incorrect. Now I have to go through argument 2. Stone gains maximum velocity when it reaches to the maximum height. When the stone reaches to maximum height, its velocity becomes 0, not maximum. This is not correct. It means argument 2 and statement are incorrect is told. Statement is incorrect, previously decided. Argument 2 is incorrect, this is also decided. Only argument 1 is correct. Yes, this option is correct. But we have to check third and fourth option also. Only the argument 2 is correct, but argument 1 and statement are incorrect. This is wrong because argument 2 is not correct. Both the argument are correct, but the statement is incorrect. This is also wrong. That's why the option number 2 is correct, and this is the correct answer of all these statement and argument. Okay, I told you many things today. We started from distance and displacement, and we studied about this speed also, velocity, average velocity, initial velocity, final velocity, and scalar and vector, and this acceleration also. Acceleration, negative acceleration is called retardation. All these terms are very, very important to understand the motion of the body, and I think now you are able to define all these type of motion, and you can express, I mean to say, you can explain this to other also. Okay, today's time for today's class is finished. This much for today. Thank you.